All right, in this application, you're on a boat in Lake Tahoe and accidentally drop your sunglasses into the lake. Darn. At the spot where your glasses hit the water, a small wave forms, and concentric circular waves begin to propagate out from the spot where your glasses fell. Concentric circles. There you go, just like that. That is where your glasses dropped. The radius of the circle increases at the rate of 5 inches per second. So for every second that goes by, the radius is larger by 5 inches. R sub t represents the radius of a function of time, assuming R sub 0 equals 0, meaning if no seconds have gone by, then the radius equals 0. So this means 5t. That's the radius. That's how it works. A sub r represents the area of the circle as a function of the radius. Well, area of the circle is pi r squared. So we are going to say that it is r squared. Find the composition of the functions that represent the area as a function of time. So we are going to replace this. So it's kind of like saying a sub r equals pi r sub t squared. Okay? Over here, it's going to be the area is r sub t, like that. So this then equals pi, r sub t is 5t, the whole thing squared. Now we're going to simplify that because a common mistake is for people to square the t and forget to square the 5. So we're going to square the 5, and that's 25. So we're going to have 25 pi t squared. This is the area of the circle as a function of time. Find the area at t equals 3 seconds. Area of time, that equals 25 pi 3 squared. It's going to be here we go. It's okay. So 25 times 9 times pi. So let's see, that's 25 times 9, 225 pi, which is approximately the area is going to be this, and what unit of measure was the radius in? Inches. So it is square inches. That's how large the circle is going to be. Okay? All right. Now, in the next one, we're going to work a little bit backward, okay? We're going to do what's called decomposing the functions, decomposing. And all we're going to do is we're going to take something complicated and we're going to break it up into 2 different functions. Okay? All right. Here we go. There is a big careful part. You cannot let f of x equal x and g of x cannot equal x also. All right. So you take a look at this u of x function. All right? And we need to break it into 2 separate functions. So what I do is I look at the outside part, and that's a square root. And then I look at an inside part. Okay? It has to look like this. So it has to look, we need an f of x function, and we need a g of x function. U of x is a g of x function inside of the f of x function. So what is the function inside? X plus 8. And the function on the outside, if we replace that, is the square root of just x. If I did this, I would say f of x plus 8. I go back. If f of x is just the square root, it is the square root of x plus 8, and I'm all set. Okay, take a look at this one right here. I've got a cosine function. That's my outside function. That's going to be my f of x function. Just simply cosine of x. My g of x function is the stuff on the inside. That is the cube root of x. This going into that. take a look at this one. You've got the inside part, and then you have the outside part. The outside part, it's a simple x to the 6th. The inside part is all that stuff right there, and that's going to be x squared plus 3x plus 2. Look over here. You've got an inside part and an outside. F of x equals 2 to the x. The g of x is the x plus 3. All right. Now, what happens if we need 3 functions? Okay? And we have to be very careful about the order. Again, we can't let any of them just equal x. All right. This, you look at the very inside. Okay? Now, what it looks like to me is that m of x equals f of g of h of x. Okay? So the very inside one is h. So what is the very inside? H of x looks like it is x cubed plus 4. What's next? Well, what's next is the square root. And what's the outside of that? Tangent of x. This goes into there, and then that goes into that. They build and they create this. All right, next one over here. What is the insidemost function? Right there. H of x equals 2x plus 1. G of x is the next thing on the outside. Looks to be x cubed. That's in the denominator, which means that f of x is simply 1 over x. This would go underneath, and then this would go inside of there. Next thing over here. Okay, now, the thing to notice about this, you see that little 3 there? The way that it really can be written is cosine of 2x plus 1, and then everything is cubed. Now it's easy to start from the inside. H of x equals 2x plus 1. G of x equals cosine of x, because that's the next thing on the inside. And f of x is your outermost function, and that is x cubed. All right, take a look at this one here. This one's a little trickier. Kind of looks like there's only 2 parts, this part and that part. What we can do is we can focus on that maybe to be our inside part. H of x equaling sine of x. G of x equaling 1 minus x, where we stick that in there. And then f of x equaling the square root of x. All right. Okay. All right. One of the last things that you'll need to do. A product of functions is obtained when we multiply 2 functions by each other. A composition of functions is when we use the output of one function as the input of another function. Which of the following is a product of functions? Which of the following is a composition? All right, when you see functions inside of one another, they're compositions. Okay, when you see multiplication, it's product. Here, we have multiplication going on. That's a product. What about this one? That's right, it's a composition because this is inside of the sine function. Okay, take a look at B. Composition. This is inside of that right there. This one, you've got this piece times that piece. Product. This one, composition. Sine is inside of the cosine. On this one, it's a product because cosine is being multiplied by sine. This one, again, all multiplication. 3 times x times e to the x. That's a product. Here, we've got something inside. It's more complicated, it's inside. That is a composition, right? Okay. Graphical interpretation. Come back to that in the next video.